Hey there, it's Nigar, and in this video, I want to get my hands on, as I told you earlier, and take a look at linked list implementation in C Sharp. As you can see here, I'm in Visual Studio environment. I want to know how to implement a real linked list in a real life project using C Sharp, lovely C Sharp. As I discussed earlier, a linked list is a linear data structure which stores elements in the non-contiguous location. The elements in a linked list are actually all of them are linked with each other using pointers. Or in other words, linked list consists of nodes where each node contains a data field and a reference, which we call it linked to the next node in the list. In C Sharp, linked list is the generic type of collection, which is defined in this namespace, system.collection.generic. And if you want to use linked list, such as used here, we have to use this namespace. It's a doubly linked list, therefore each node points forward to the next node and backward to the previous node. It's a dynamic collection which grows according to the need of your program, and it also provides fast inserting and removing elements, as we discussed in the previous video about the functionality and the runtime of the linked list and comparing them with arrays. Okay, so there are important points that worth to mention as I list them here in the environment of the Visual Studio. First and most important one is the interfaces that a linked list class actually can implement. As you can see, interfaces can be iCollection, iRead-only collection, iDeserialization callback, and iEnumerable collection. A linked list also supports enumerators, and you can remove nodes and insert them either in the same list or in another list, which results in no additional objects located on the heap. Every node in a linked list object is of the type linked list node. It means that all of them have the same type. It does not support chaining, splitting, cycles, or other features that can leave the list in an inconsistent state. Also, if the linked list is empty, the first and the last properties contains null. It was mentioned that the capacity of a linked list is the number of elements the linked list can hold. Last but not least is that in linked list, it is allowed to store duplicate elements, but of the same type. So what if we want to create a linked list? So we have to use linked list class, as you can see here. I create a object called string links of the type linked list, and all the nodes in this list, in this linked list, to be more specific, are of the type is string. So it means that I can add elements and I can have elements of the type string in this specific linked list. Linked list provides four different methods to add a node, and these methods are add after, add before, add first, and add last. I will discuss about each of them by using codes. For example, if I want to add a node or an element of the type string, I have to use add last method. As you can see here, I use add last method to add, for example, Daniel, Alice, and Sheldon to this linked list. And if I want to actually have a output of my list, I have to for each loop through my linked list in order to access each of the nodes. So I used a for each loop here, and I called each of them a string nodes. a link in the whole string links, which is quite simple. And if I press the run button, we will see the list. As you can see here, best friends of mine are Daniel, Alice, and Sheldon, as I add them here. If I want to add another one, for example, I don't know, Leonard, it would be like this. I want to add Leonard at the last of my list. So I have Leonard here. Okay, there are multiple of methods that we can use with our linked list. For example, if I want to remove the first node of the list, I can go two ways. First of all, I can use remove method and just call the first node of my list. Here I can say string links, which is my list, and I call the first node, and then I want to remove it. My first node here is Daniel. I want to remove Daniel here. So if I let me just move it here, and if I press the run, we can see here that we do not have Daniel here. We just have Alice, Sheldon, and Leonard. And there is another way. We can say string links, which is my list, and we can just remove first by the help of method with that name. So I comment this out and I press the run again. And you can see that, again, we don't have Daniel on the list, which is our first element. Very well. There's another method. For example, imagine that we want to remove a specific node. What we should do? We should, again, call a list and again remove method and say, for example, just remove Alice from the list. So we can do such a thing by calling this specific node. Here it's Alice. Press run, and we can see that there is no Alice in our best friend list. What if I want to remove the last element? We can use a method called remove last. So we have to call our list and use remove last. Press the run. We can see that there's no Leonard here, which is our last element of the list. Perfect. Imagine that we want to clear the whole damn list. Clear the whole list. What we should do is call the list and just clear it by the help of method called clear. So if I run the program, there's nothing. To be more specific, let's comment this part out. And you can see best friends of mine. There's an empty list. Okay, what if I want to check the availability of a node here? Check the existence of a node. I want to check if there is any node named Daniel or there is not such thing as Daniel. We can use if and call our list, which is string list, string links, and check with the help of contains, check if there is Daniel in the list. If it is, just print the element founded. The element found. And if there is not, else, just print not found. So I have to find this part out and press run. Best friend of mine, the element found, because we have element called Daniel. Let me comment here. And let's check if there is Negar in the list. Run it. Not found. There is no element named Negar in the list, as you can see here. So that's it. That's the most important actually points and remarkable methods that you can use with a list. You can define a linked list of any type. I use the string here. You can use methods such as add last, add first, add before, add after, and you can clear the whole list, remove in a specific node or other methods that we use here. And there is more. I will complete this collection of all methods that we can use in linked list, and you can see the complete source code in my GitHub. The link of my GitHub is the description, as well as my profile page. You can find in both places. And just that, I hope this video helped you even a little to get to know more about lists, linked list, by the help of C#. And just stay tuned and don't forget to subscribe. See you in the next video.